Hello everyone, I'm Xiansheng Math, and then this is part 2 of how to convert a decimal, one that does not terminate but eventually repeats, into a rational number in fraction form. Part of the reason I have some of this language here, it's to align with this standard. Okay, so we see 0.47 repeating, so 0.47, 47, 47, 47, going on forever. And we want to change this into a rational number that's in fraction form, as we saw in the first video. I'm going to use this equivalent form of the number. So, getting the idea, well, first I'm going to assign a variable to this decimal number, and the idea here is to create a situation in order to eliminate the repeating part. And then from there we can show that it's a rational number in fraction form. I'm going to first look at 10t. Well, if we multiply t by 10, we have to multiply this by 10. So the decimal will go one place over, so we'll have 4.747474. See, that's repeating. If we multiply t by 100, we get 100t, and try to make t's consistently, and that equals, well, the decimal's going to move two places, so now we have 47.474747, and we'll look at 1000t, and that will move the decimal three places over. So we'll get 400. We got to make sure the place value's lined up. So, well, what's the decimal part going to be? The decimal goes here, so it's going to be 0.747. So 7474. And 474. So line up ones with ones, tens with tens, and then here's the hundreds. And I'm just going to stick 10,000t in there. All right, so the decimal place is going to move 4 places to the right. So the decimal part is going to be 0.4747. So I'm going to put 474747 and 4,747. So ones go with ones, tens with tens, hundreds with hundreds. Okay, some might say this is making it more complicated than it needs to be, but I think the importance here is showing, emphasizing the fact that you need to eliminate the repeating part. So let's say I tried to do 10t minus t. So I'm going to go 10t, which equals 4.7474, and I can stop there. And t is 0.4747, and so on. All right, and here I see, whoops, that's t. All right, I see that the repeating part and this part also, well, no, it's the emphasis on the repeating part. The repeating part does not match up. If I subtract this repeating part from this repeating part, it does not equal 0, so using 10t and t will not work. So let's see. If I look at 100 T and T, looks like in tens place, hundreds place, thousands place, 10,000s place. Looks like this will work, so I'm going to try 100 T, which is equal to 47.4747. The 47 repeating, and I subtract T, and you put the minus there, and it doesn't matter, this is going to be 9T, but that doesn't matter, we can't work with that. So 100T, and I'm going to subtract T, and T is equal to, line up the place values, tenths with tenths, hundreds with hundreds, thousands, 10,000s, and so on. All right, in this case, I see, yes, the decimal places, each value matches up. So I see that if we were to subtract this part, the whole decimal part, and sometimes the decimal part doesn't become 0, but as long as you're eliminating the repeating part, it'll work. So if we subtract T from 100T, we will get, well, this part is 0, so we'll just get 47 minus 0, that's 47. And then we do 100T minus T, we get 99T. So we have 99 times T, and to undo multiplying T by 99, we do the inverse operation, which is division, so we divide by 99, and we must do the same thing on the other side to keep the balance. And this is 1 in disguise. So we have 1T, which is just T, and that equals 47 divided by 99. So 0.474747 repeating is equal to 47/99. Okay, why did I go through this trouble? Again, it's to see which ones, to emphasize the idea of to do this properly, you need to eliminate the repeating part. So you must have the repeating part be the same when you subtract. So that's why 10T and T didn't work, because we see if we have the place values lined up that these aren't the same. We see with 100T and T that they are the same. We also see 1000T and 10T have the same repeating part. And 10,000T and 100T do, as well as T. So I could have used 10,000T and T. I could have used 10,000T and 100T. You could also use 1,000T and 10T. I'm going to go through this one quickly, again emphasizing the idea of you need to eliminate the repeating part. And I apologize for making this video longer, but it does, I think, illustrate that point. So I'm going to do 1000T minus 10T, and I see here that the place values are all the same. So when I do subtract, I will get rid of the repeating part. It will be 0. So 1000T is 474.7474 repeating, and 10T is 4. Ones go with ones. Tenths and hundreds go with tenths and hundreds. And what I see here that's important is the repeating parts are the same, so when I subtract, they will become 0. In fact, the entire decimal part does become 0. So when I subtract 10T from 1000T, well, that part's 0, so we'll get 474 minus 4, so that's 470. And here, we take 10T away from 1000T, we get 900T. 90t. And we want to undo multiplying by 990, so we divide by 990, we do the same thing on the other side, and that's one in disguise, so we got 1t, which is t, equals 470 divided by 990. These two numbers have a common factor of 10, so I'm going to divide by 1 in the form of 10 divided by 10, and this is equal to 47. The denominator is equal to 99. And again, we see that t is equal to 47 divided by 99. So 0.47, 47, 47. Repeating is equal to 47/99. Again, the point to remember here, if you're doing this, no matter what the repeating decimal form, you need to eliminate the repeating part, so you need to choose which multiples of t to use. So we see that these two will work together, these two. We also see that these two would have worked together. I hope you learned from this video and enjoyed it. Thank you for watching, and please hit like and subscribe. Thank you again. 再见。